Okay, so I want to show you how to make a bouncing bubble. You will need three things. First thing, water, soap, glycerin. This is glycerin. So you mix these three things together. I already have the mixture. 70% of water, 10% of soap, 20% of glycerin. The ratio could be rough, you don't have to be exactly 20%, 10%, 70%. Could be rough. Then you have the mixture here, and I also have a straw ready. The straw. Then you dip the straw into the soap. Dip the straw there. Lift up. Use my mouse. Blow it. See, it's bumble. See? Yeah? Busted. Anyway, it's very hard to do that with one hand holding the camera and another hand holding the straw and the clothes at the same time. So, and I'm gonna explain the scientific side of it. Here is the clothes I use. See, it's rough. It's rough. There's some cotton ball, You can see the surface is rough. You must choose something rough and also clean. Clean and rough. That's all you need. Now you can use a glove, and I didn't find any glove, so I use the bouncing ball itself is made of water and surfactant. The surfactant is a surfactant on the surface, out layer, and also the inner layer. And the inside of the ball, that's water. Okay, and between the water and air, between the water and the outside air, that's surfactant. Between the water and the air inside, that's surfactant. So the bouncing ball itself has three layers. The first, outer layer is surfactant. Inner layer is water. Inside the layer is surfactant again. Okay. And it keeps the round shape, the sphere shape, just because the surface area is the smallest this way. Why it do not shrink to make the surface area even smaller? Because the air sealed inside of the bubble. Of course, the air can diffuse out, but it takes time. It takes time, and it's not gonna happen in a second. So the bubble, if the bubble shrink, then it will press air, and it will add pressure, and it cannot shrink. The outside pressure and the inside pressure should be the same. And the bubble itself is made of surfactant, water, and surfactant. And I want to keep the surface tension the smallest, which means we want to keep the surface area to the minimum. So it want to keep the sphere shape. Again, I want to keep the round shape. But if this round bouncing ball touch the smooth area, if it touch the smooth area, part of the ball is gonna touch that, and it's gonna stick to the smooth area. Once it stick to the smooth area, the rest of the surface tension, it depends on the rest of the ball, which means the surface area get cut. Surface area is reduced even less than the round shape. So it means, I can even get a smallest area. Why not? Why not? I can get a even smaller area, right? So it busted. But if I use a cotton clothes with a rough area, so it means there's a lot of rough spike cotton ball on the surface of the cotton clothes. And once the bouncing bubble touch the clothes, all these spike gonna poke the bouncing bubble, which increase the surface area. Again, it increase the surface area because it change the shape of the bouncing ball. It changes the shape of the bouncing ball, and on the bottom of wherever it touch the rough surface. So it change the shape. So therefore, it increase the surface area. And if it increases surface area, it increases surface tension. So it want to go back to its round shape. So it bounce back and go back to its round shape to reduce the surface tension. That's why